Welcome to my video lecture on base isolation techniques. To start with, we'll get a brief about what is known as base isolation. Base isolation is one of the most important concepts for earthquake engineering, which can be defined as separating or decoupling the structure from its foundation. In this, we generally try to separate the foundation and the structure so that the effect of the earthquake is minimized. In other words, base isolation is a technique developed to prevent or minimize damage to building during an earthquake. In brief, earthquake is the generation of seismic waves due to the movement in the tectonic plates. Base isolation technique. It might be thought that the structures can be protected from the destructive forces of earthquake by increasing the strength of the structure so that they do not collapse during such events. There is a drawback of this concept that in making the structure more resistance to giving it more strength, there is a chance of making it more rigid. If the structure becomes more rigid, then the result is that there is a lot of damage that is possible due to high rigidity. In other words, more rigid attachment of the building to its foundation will result in less damage in an earthquake. The principle of strengthen to resist damage. However, if the foundation is rigidly attached to the building or any other structure, all the earthquake forces will be transferred directly and without a change in frequency to the rest of the building. That means, as just explained prior, that if your structure becomes more rigid, then there is a chance that the structure ultimately behaves like a brittle material and there is a chance of failure in the structure. Thus, providing a base isolation device between the building and the ground can minimize the level of earthquake force transmitted to the building. We basically try and concentrate detaching the base and the structure so that the forces that is transmitted, forces in this case, we refer to the seismic forces that is generated due to the earthquake. We can reduce the seismic forces that is transmitted to the building if we are decoupling or if we are separating the structure from its base. Here we can see there is a pictorial representation of a conventional structure as well as a base isolated structure. The conventional structure, when it is hit or when it is acted upon by your seismic waves, they get deflected and there is a vigorous movement in the structure. Whereas if you observe the base isolated structure, though the base isolation or your base is subjected to seismic wave, the effect of it is not seen much on your base isolated structure. That is, the deformation in the structure is less as compared to that of the conventional structure where there is no base isolation techniques used. And this is generally because of the fixity in the conventional structure. If the natural frequency of the building coincides with the frequency of the earthquake, then the structure will vibrate vigorously, leading to huge damage. This can be just elaborated by the diagram of conventional structure, wherein there is a possibility that the natural frequency of the building and the frequency of the earthquake generated is same, which will lead to heavy damage in the structure. Whereas by using techniques like base isolation, there is a possibility or there stands a chance to change the natural frequency of the structure so that the frequency of the structure and the frequency of the earthquake does not coincide, and which will ultimately lead to reduced failure in the structure, or chances of failure will be very less. Here, this schematic representation shows two basic components of base isolation. That is, one is your isolated bearing and the second is the passive damper. This technique is known as your base isolation system, that is separating your superstructure from your foundation. The former protects, that is the base isolation bearing protects the superstructure from collapse because of lateral movement based on earthquake forces, whereas the later, that is the passive damper, dissipates the energy that base obtains during an earthquake. In this system, it makes clear that the bearing is used to detach the structure from your base, whereas if not 100% decoupling of the structure from the base is possible, then we have passive dampers which will dissipate the energy of the base and dissipated energy will be transmitted to the superstructure. That means in both cases, the effect of the seismic waves or the earthquake forces is reduced. Coming to base isolation system. The base isolation systems are usually elastomeric, and the second famous one is the sliding bearing. If necessary, it could be combined with supplemental dampers. Now, a best example of damping is rubber, maybe lead, and many other systems as well. The schematic representation of there are two schematic representation of multi-layer elastomeric bearing and the second one lid plug bearing. In case of your elastomeric bearing, there is a sandwich layer of the rubber bearing and steel rim alternatively. This helps in detaching the structure from the base. This is one of the most famous base isolation system that is used worldwide. The second available is the sliding bearing. As examples of sliding bearing could be roller pin, could be rocker pin. These are simple examples of the sliding bearing. The sliding bearing systems have become famous nowadays, but still on a large scale, the elastomeric bearings are being used. These are some of the base isolation techniques that are recently used. Also, there are some other damping systems like the viscous dampers, which indicates this could be combined with the dampers. If in case the seismic waves are transmitted to the structure, then the supplemental dampers like your viscous damper could help in reducing the intensity of the seismic wave that is transmitted to the structure, which ultimately will help in reducing the damage caused or the possible damage that might be caused to the structure. In 2002, after the Bhuj earthquake in 2001, the Bhuj hospital was constructed or was designed and constructed for earthquake resistant structure. This pictorial representation gives the view of the basement in the Bhuj hospital, and the arrows indicated shows clearly the base isolators that are provided at the basement columns. Now this basement columns ultimately separates the structure from the base. In this case, whenever an earthquake is generated or earthquake occurs, the seismic waves that are generated because of the earthquake, if in case it hits the structure will immediately decouple from the base. So the minimum effect will only be occurring or will only be caused to the superstructure. So this is a live example, and the hospital is steady and it holds true at Bhuj. Photo courtesy EERI USA. Thank you so much. This was an introductory video on base isolation system. Stay tuned for more videos.